All right. Welcome to Intro to Statistics. We are talking about hypothesis testing here. So, the idea with hypothesis testing is it's something that we're going to put numbers on things. We can't just say, "Well, I think this is happening." I'm like, no, no, no. You have to say, "I think this box of cereal weighs 16 ounces, or this box of cereal weighs more than 16 ounces, or weighs less than 16 ounces." So what we're going to do is we come up with two competing hypotheses. Okay, we have HO, that's pronounced H no or H0. Okay, and we're going to that usually gets the equality. Okay, if there's an equal sign, it's going to go with H null. Okay, this is your null hypothesis. Okay, so this is the null hypothesis. This is where the benefit of the doubt is given. So if you look at your cereal box, or if you look at your package of rice or whatever you've bought, and the manufacturer says 16 ounces of cereal in this box, we're going to say that the average weight is going to be equal to 16. Now, if you're on the side of the cereal maker, okay, your alternative hypothesis, okay, HA, this is called alternative hypothesis. This is technically what you're trying to prove without saying this is what you're trying to prove. Okay, so you don't want to say this is what you're going to prove, but really this is what you're trying to show. Okay, and sometimes it's not a good thing. Okay, if it's a two-tailed one, okay, that means it could be upper or lower. So if you're from the point of view from the cereal manufacturer, okay, you really want the customer to get that 16 ounces. You don't want to give them more because you're losing money. I know cereal's expensive, but you don't want to give them less because you're going to get sued for false advertising, and that's going to cost you money too. So, from the point of view from the cereal maker, your HA, your alternative hypothesis is I'm going to see whether or not my average is not 16 ounces. Because if it isn't 16 ounces, then you got to go back to the whatever machine is pouring that cereal in, and you got to go fix it because you want exactly 16 ounces, or at least 16 ounces within a reasonable amount of error to be in that box. Because again, you don't want to give away too much product. You want to overfill a little bit, but you certainly don't want to underfill and open yourself up for a lawsuit in that direction. Okay, so this is called a two-tailed test because it's a little bit over, that's not good. It's a little bit under, that's not good. So that's called a two-tailed test. So if you see this inequality here like this is two-tailed. If you were given nothing else, you know nothing else about the problem, you know nothing else about the situation, and you say, well, I have to guess, if I want to make this one-tailed or two-tailed, make it two-tailed. Okay, it's a more robust test, but that's pretty much what you're looking at there. On the other hand, what if you're the consumer? Okay, and you're buying your cereal. You say, okay, well, HO, they said again, you give the basis of the claim to the manufacturer. They said there's 16 ounces in there. We'll go with that. Now, if you're a consumer advocate, you say, well, you know, my kids go through this cereal really fast, like faster than they normally should. Okay, so you might think maybe there's less than 16 ounces in there. Okay, this would be a one-sided test. Okay, so your alternative hypothesis here, okay, is that there is less than 16 ounces. Okay, your null hypothesis, okay, this is still the null hypothesis, H sub 0, null hypothesis that there is 16 ounces because that's what's posted on the box. The alternative hypothesis, which you're trying to prove, you're like, well, my kids go through this cereal really fast. Maybe there's less. Okay, and that's what you want to prove. Okay, so if you're a consumer advocate, you're going to go out and weigh a whole bunch of different boxes of cereals and see whether or not that average is going to be less than 16 ounces. Okay, and then the other thing I would recommend that we do, they don't force you to do this in the book, but when we do face to face, I always give you guys the what's going on here, and I would say, what is my threshold of proof? And my threshold is always going to be, well, it's not always going to be 0.05, but when they're going to say test at the level of the 0.05 level of significance, okay, so I would always say when you do your test of hypothesis, you want to state your level of significance as you're stating your hypothesis. Why would I want to do that? Because if you do it at the end, you're going to know what that probability is. You've done the calculation, you're going to know what the probability is. At that point, you could make your level of significance anything you want. And if your test doesn't fall underneath that level, you're going to say, well, we're just going to do that. So this is where you run into ethical problems. Because if you don't set your level of significance until the very end and just say, well, we'll figure it out when we get there. Like, well, that's bad. You should test it. This is the level, this is the standard you want first. Then you do your tests, then you do your measurements, then you do your probability, and then you see. If you don't do this and you say, well, I think it's going to be 0.05, and then if it comes out to be 0.06, then this is what's going to happen. With medical testing, they'll say, hey, we think you should find that this drug makes a difference. And if you came out with 0.06 rather than 0.05, you're going to say, I'd like to keep my job. I just bought a new house. I got a wife and kids. I got just got married. Maybe I'd like to keep my job. So maybe we're going to change the level of significance that I'll accept once I know what the answer is, in order to meet this demand of like, we're going to show this thing is effective. That's not good science. Okay. So I would say when you're doing your test of hypothesis, and again, your book does not address this. They just talk about one-sided, two-sided for now, one-tailed, two-tailed. For right now, just to get through this problem or to get through this idea, if it's an inequality like this, it's a two-tailed test, okay? This one, two-tailed test. It could be lower or higher. That's an issue. If it's just higher or lower, exclusively lower, then it's a one-tailed test. The other example I give is, I don't remember what the exact value is, but I used to live in Belen, and in New Mexico, we have a problem with arsenic in our drinking water. There is just naturally occurring arsenic in our groundwater. It happens. Okay, it's not that somebody's trying to poison us on purpose. They might be, but it's just there. Okay. In Albuquerque, they also have fluoride. But what happened is that the water people come by and they test the water every year. And you might say, well, I think, the EPA said it's safe. Like, okay, we'll trust them. And say for just the sake of argument that they said that we have 50 parts per million of arsenic in our drinking water. You're like, well, I've got really dry skin and nobody's feeling really good and people will run down and you go look up what the problems with arsenic are, and you say, oh wow, all of these things happen, all these effects are happening. We might be getting more than our daily recommended allowance of arsenic in our drinking water. So you don't care if it's under, but you are going to care if you're getting more arsenic than you should, okay, when you're drinking your water. So again, this would be a one-sided test. Like, we don't care about less than the daily recommended amount of arsenic. We want more than the daily recommended amount of arsenic. That's what your suspicion is. So you're trying to prove this. So you're going to go out and take little independent samples and figure this out. If it's more than that, you can go back to the EPA and say, hey, wait a minute, what's wrong with our testing methods? Fix this. Okay, we have a whole population here that is getting more arsenic than they really ought to be getting in their daily lives. Okay, so one-sided test, it's bad if it's on one side. Again, we're getting too much arsenic. That's not good. Or if you're making cereal, so a more lighthearted example, and you don't want to give this, you don't want to give your, if you're a consumer, the point of view from the consumer, you don't want to be getting less cereal than you're paying for. You don't care if you get more, but from the point of view from the consumer, you care if you're getting less. Now, if you're from the point of view of the producer, okay, then you care. You don't want people to get less than what they bargained for, because you give a customer a good product, but you certainly want to be giving them more because that's cutting into your profit margins. Okay, so you have to worry about both sides. If it's more, that's a problem. If it's less, that's a problem. So it really depends on who's doing the test as to whether or not it's going to be one-sided or two-sided. But like I said, if you don't know, if you have no other context, pick two-sided, and because that's a more robust test. But sometimes, we only care about one side. In this case, like, nobody's going to complain. Like, I'm getting less arsenic than I really need. No, nobody has ever said that. Okay. So that's what we do with that one. Okay. So that's how we get started with this. All right. I will leave you until the next video. Thank you.